Alright, so for the last couple of days, I've been working on certain hashing strategies with the intention of using them for my DFA construction for my Regex engine thingy. So, one video, I think the second version 2 of the Regex engine, the second video, I talked about sort of how DFAs worked and how I would be trying to convert from an NFA that we got by Thomson's algorithm, how I would convert that into a DFA, and I talked about the nodes and like all this stuff and the epsilon closure and the move operation, and I talked about how I was roughly planning on implementing it, but I wasn't 100% confident. Now, we have some tools available to us, not that one, primarily the Zobrist hashing and the other hashing, wherever it is, hash set, this package, which lets me basically have sets and have hashed sets. Let me figure out if I've created a set very quickly, and lets me collect sets of integers a bit easily. Which, because remember, this algorithm, the subset construction algorithm, which is how we're going to be creating the DFA, relies on having sets of integers, because a DFA node is basically a set of integers like this, right? So that's important. And also you have to be able to check if a particular set has been created before when you do this part of the algorithm. If a new node set exists in the DFA node already using some kind of hash set, but in this case I use Zobrist hashing, then you don't have to create the new node, you just have to create an edge. But so that's what all that work was for, and now I think I just about have enough to be able to go through all of the whole algorithm. So I was kind of, just out of like refreshing, I kind of rewrote the algorithm in my own words, sort of just scrappily, trying to annotate where I think, I need to pay close attention. What I'm thinking of doing today, see if do it for like half an hour, is like, first things first, I think I need to create a table, because right now my NFA is like, it has a start node and an end node, and then you have to DFS in order to find all the other nodes. Like if I look at the NFA stuff, NFA construction, that's wrong. Why did I do that? NFA construction include the NFA stuff. Like an NFA consists of an initial, a terminal, and a size. How many nodes? But it doesn't. I can't get all the nodes just from this object. So what I'm thinking is, if I do a DFS, then I should be able to essentially get the. I should be able to get all the nodes by traversal, and then create a table that lets me, quickly look up all the nodes, all the NFA nodes, because I think that would be helpful. And then being able to look up a node means I can find all its edges, and then I can find all its neighbors, kind of thing. So I'll have to do that. So that's the first step. Get the NFA, DFS through the NFA, and then make a table. Then I need to make sure I have a function that lets me do an epsilon closure. We talked about that before. Basically, epsilon closure is given a particular set of nodes. Which nodes can I? This is NFA nodes. Given a set of NFA nodes, which other NFA nodes can I reach via epsilon edges, empty string edges? And I also need a function for moving, which is basically a similar idea, except given a set of NFA nodes, what nodes can I reach using exactly one edge that is labeled with an input character. Right, so we'll talk about that a bit more, but for now, I think I want to sort of create my structs that are sort of useful. So I'll have like a DFA struct maybe. That kind of works like I think I'll start with saying DFA node. I should call this NFA node, I think, but for now I'll leave it. Struct DFA node, which will basically have a hash set. This will be this hash set is from the hash set that I wrote beforehand. Managed to fix the bug that I was having before and have added a bit of extra functionality, but nothing crazy. Anyway, so the set, maybe an ID as well would be good. And anything else? I'm sure there's something I've forgotten now. Ah, is it a start node? No. Is it a finishing node? Because unlike the NFAs we create with Thompson's algorithm, the DFAs we create can have multiple finishing nodes. It's possible, so easy way to figure out if something is a finishing node. Just have a Boolean flag. That might be it. And then yeah, the DFA. Oops. I can probably get away with having a DFA node start. What's wrong with that? Oh, of course. Sorry. Forgot that it has to be like type def. And same thing over here. Okay. So we have these structs. Yeah, and I probably want some kind of table, but I probably don't need to make a struct for that. So yeah, what did I say? So I want to create node. I think I have to call it NFA node, otherwise I'm going to get really confused. One, two, 3, 4, 5. 1, 2, 3, 4, 5, 6. So if I replace that with NFA node, we should be fine. No? Ah, right, of course. Okay, should be okay now. Yeah, so NFA node, it's going to be an array of pointers, so double pointer. Get NFA lookup, and this is basically going to be given a particular NFA. This is basically going to be an application of DFS, but we're also going to set it up. So NFA node lookup equals, I need the standard library. Well, I've included the standard library somewhere in these libraries or in these already, so I should be fine. Size of NFA node star, because the actual element is a pointer. And how many do I need? I need enough. I need enough for each node, which should be the size thing from memory. I'm pretty sure. That really should be called num nodes. It's not very clear. Yeah, so we get a block of memory that lets me, and then get NFA lookup DFS. So given the table, and give it maybe a visited thing, right? So, so setting up I guess I can calloc actually. I'm going to say NFA size and then size of bool. So the visited array, we have the lookup thing that we're trying to construct. I need a source. Which I'm assuming will just be 0 at the start. But I guess I can be specific about that. Get NFA lookup DFS. Given the source, I can say initial ID just in case. So get the source, the lookup, and the visited thing. How does this work? So for a DFS, you have to look through if it's already been visited. Yeah, if it's already been visited, no point doing it again. So if visited source, don't I need a previous as well or no? Int source int previous, so you don't go backwards by accident. Do I have to do that? Because the previous will be marked as visited already, so we'll just return, right? Otherwise visited at source equals to true. And then for int I equals 0, I should be less than should it be actual nodes? Because the neighbors are also nodes, right? Okay. I should be less than source edges size plus I. So this is our way of getting all the neighbors. So for each neighbor, do I check if it's visited or? I mean, I guess this will do it, so it should be okay. Get NFA lookup DFS given the source edges data at I, so getting that particular edge, the neighbor. So get that guy, pass this guy in as source, give this guy for lookup, and visit it like this. And we can also say, maybe I can be like edge star current edge is equal to this. And like, if current edge neighbor if it's equal to the previous, then continue. Should I do that? Do I need to do that? I feel like this will handle that for me, but anyway. Visited source ID and look up at the source ID should equal the source's address. So yeah, something like that should basically build the table for me, because I'm going through all the nodes, making sure they all get visited, and yeah. So then I can free the visited array, and I can return lookup, which is the address to this big table. Oops, sorry. So that's this part. Get the NFA, make the table. That's good. I need a thing for epsilon closure. Why is it red? What's wrong? View2. What else did I need? Previous. We'll say null, because I only use it here, so there should be nothing illegal about that. That should be fine. Okay. I don't really know what epsilon closure. I guess it'll be a set, won't it? Hash set star epsilon closure given a particular node. I guess I'm doing like a okay. Given a particular NFA node, and a particular, maybe I want the no, sorry. I'm gonna take in the whole set, hash set. This is a DFA node. The hash set is a DFA node. Maybe I can even no, never mind. So given a set, NFA nodes, I'll call it like that, because DFA node is its own thing. So a bunch of set of NFA nodes. I have to get the lookup as well. So that was a NFA node star lookup. That will let me go from ID to node. So for each, I have the set of nodes. I have the epsilon closure. It's a bunch of DFSs, isn't it? Epsilon closure DFS. That might be it, to be fair. Okay, wait, so okay, so hash set NFA nodes. So I want to go through each NFA node. So I need the iterable. I have a thing where I can make an iterable. Hash set iterable equals get iterable given the particular hash set, which is called NFA nodes. So this gives me an iterable, and then for int I equals 0, I less than iter size. So for each thing in the iterable, for each item, so iterable at I gives me access to the particular node. No NFA node star current is equal to that guy equals lookup index at this guy. So I get the particular node I want. I don't think I need this. Initially it will create this set. So hash set closure, the closure we get is equal to, what is it, hash set init. So we get an initial hash set which is empty. My bad, wait, why did I get rid of that? What am I trying to do? Yeah, that should be fine, I think. Yeah, so this iterable captures the nodes at this point in time. So if I add to the set afterwards, it won't affect the iterable at all. So it should be fine. NFA node current equals lookup in that point. And then we're going to do the epsilon closure DFS given the particular current. And that's going to search through the graph looking for epsilon edges and adding two NFA nodes. It's going to add the NFA nodes. It's going to add two NFA nodes, any nodes we can reach via epsilon edges. Epsilon closure. So we're going to take a NFA node and we're going to take in. I need a visitor, don't I? Oh god. But the visitor can be like an outer visitor. I don't have to create a new visitor every time, because once I've hit a particular node once in one of the sources in here, I don't need to re-examine it for new sources, for new NFA nodes. So I should just create one visitor, bool star. Now the interesting part is, I think I need to use hash set this time. I can't use a contiguous array because I don't know what these numbers are in here. They're not going to just be numbers from 0 up to n. It's going to be random numbers. So I think it's actually better if I create a hash set. If I do this, and then I free it at the end. So it'll be like hash set free given the visited. Visited. Something like this. Is that wrong? Too many. Sorry, epsilon closure DFS. Is that still wrong? Oh, sorry. I didn't do something. So I need this. I need the NFA nodes as well. Do I need that? Yeah, because I want to add new nodes to here if I can find them. Okay. And then if hash set exists in visited, if the source's ID exists in there, then return, because we don't need to keep going. Otherwise, hash set add to the visited this particular key, which is source's ID. So a very similar DFS idea. For int I equals 0, I less than the source's edges, plus I, if current edge, sorry, if, I'll do this as well, get the current edge, if current edge spelling, and then string compare is annoying, but what can I do? Oh, I might need guards actually. I think I forgot to do guards in some of my stuff. Anyway, it's fine. If string compare the spelling and nothing is equal to 0, right? Being greater than, equal to, or less than, yeah, so if it's equal to 0, it's the same string. So if it's an empty string, then visit this guy. Epsilon closure. Do I need a previous? Previous is purely for cycle checking, right? Previous is purely for cycle checking. Like, that's the why I remember using a previous. I don't need a previous here, I don't think. Get rid of this. Get rid of this. And get rid of this. I don't need a previous. Because it will handle it. It will say that it's visited and then return. It'll be fine. I hope. We're going to go current edge's neighbor. We're going to go NFA nodes. And we're going to go visited. If the string compare, should I just add it to the set, like regardless? NFA hash set add to the NFA nodes. Add this particular key, which is the current edge neighbor ID. And we do this a bunch of times, blah, 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 blah. And then eventually, whoops, whoa, okay. Yeah, eventually, we should have, like, when we finish with this epsilon DFS, and we do that for all the sources, we should have like a chunky set built up from the original NFA nodes. We should have a chunky set that tells us all the nodes that can be reached by epsilon edges, hopefully. Yes. And then I should also, and if I have the hash set originally, I don't need to return it, so that's fine. This can still be void if I want, but maybe I'll make a boolean because I'll also have the lookup NFA nodes. I'll call it. Wait, is that right? No, this is wrong. Sorry. Not that. I was thinking of doing the Zobrist stuff. DFA set or something, you know. With something along the lines of like Zobrist exists if in the DFA set these NFA nodes exist, set here and hash set is the same thing. I typed F that. I probably shouldn't have, but if, you know, we can return this or something. Do this first, and then we can return this maybe. And this indicates to us after epsilon closure, does the node exist, you know? Or maybe I shouldn't do that here. Maybe I should, yeah, I feel like this is actually too much for one function. I should do this, and then whoever calls this guy should check that themselves. They should be responsible for that. Okay, I think this is correct. I don't really know. So void here. I hope this is correct. Void. Okay, so I have the epsilon closure function, and then I have the NFA I need the move function. So given given a hash set again, right? Hash set of NFA nodes. Oops. Of NFA nodes. Given that, maybe given the lookup as well. Because yeah, these are a bunch of IDs I need to look up. So given this guy and given a character, I think char is fine. I don't know why that wouldn't be, because like, I guess if you're going to use like Unicode, then there'd be some problems. I'll just say using char C here assumes no Unicode, which may be unfair. I'm not really sure, but it's fine. Now, this has to create a new hash set because I'm not adding to this set here. In epsilon closure, I was adding to this set with new integers. Here, this guy and this guy are going to be two different sets. So I have to first, I'll say hash set result is equal to hash set init. And then I will say similar idea here. I don't think I need a visitor though, that's the difference. Unless I do. Yeah. Take this. So I get the iterable of the, I go through each one, I get the particular node that we're up to, and then I say something like search move search edges kind of thing, where you're giving the current and you're giving the character, and you want to see if anything good happens. Maybe give the hash set as well. So what am I saying? I'm saying avoid move search edges given the NFA node star source, given the current character, and given the hash set. What should I call it here? NFA node star source. Maybe res is fine actually. Result, yeah, that's fine. And the idea is for source, sorry, for int I equals 0, I less than source edges size. So we're going to say current edge, steal that line. Current edge is equal to that guy. We're looking at the current edge, and we're saying if, and I made a note in my OneNote saying I can't just compare, like generally speaking, let's say the symbol was A, char was A, then what I'm looking for is edges with A's on them, right? Annotated with an A. However, in Regex, for example, like the dot character, the full stop character or the period character represents any character. So if the symbol here, char C, if that is the character A, but I come across an edge that is a dot, is a full stop, then that should like work. The move function should count that as like a valid edge to traverse. So it's not as simple as just checking if the char C is equal to the spelling of the edge. That's not really fair. So another helper that I will have is something like move spelling matches or something, and it's going to take in a char C and it's going to take in a char style spelling, and based on different cases of char C, we're going to look at, you know, different spellings kind of thing. So for example, if string compare spelling and the dot is equal to 0, then return true. Like, you know what I mean? Like, if it's a dot, return true. Doesn't matter what it is. Granted, I think new line can be a bit weird, but it's fine. Like, if the current character's a new line or something, I think things get a bit weird with Regex, but I'm probably not gonna have new lines. Okay. String compare is this one, return true. If and then there's a bunch of like random cases. Switch on C, case. Imagine C is a dot. If string compare spelling with an escaped dot, turn true, turn false. You know what I mean? If the character that of the literal character in the text, if it's a dot, then to match that dot, the spelling of the edge should be an escaped dot. That's how the regex would match a dot literally. Or of course you could use the wildcard, but that would have happened by now. So yeah, either has to be that or it's failed. Any other weird cases? Yeah, white space and stuff. If string compare spelling is literally a backslash followed by a T, I think this is true. I don't really know. Anyway, eventually, default if so the default is like if so non-escaped normal characters, in which case is string len of spelling is equal to 1 and spelling at index 0 is equal to C, then return true. Otherwise, I think we can return false. This is my initial attempt at trying to have like a helper that lets me compare the incoming character from the literal text with the edge labels. That's my hope. Anyway, if move spelling matches between the character C and the current edge spelling, then the result, the hash set add result, nope, what am I doing? Hash set add to result. Yes. Oh wait, it's meant to be ampersand. I don't know if I talked about this before, but hash set add takes in the address of the set, not the the address of the pointer to the set, not the address of the set. And we're going to add the key, which is the current edge neighbor ID. Where else have I used this? Because I feel like I made that mistake a few times. Hash set add ampersand. Hash set add. Yeah. Ampersand. Oops. Ampersand. Okay. Back down to earth. Something else is red. Ah, I accidentally did something silly. There we go. If the spelling matches, then yeah. Then hash set add this one. Yeah, that should be fine. And then the res, when we return, the res should be updated as expected. Move search edges, yeah. let me check this. So we're going through each element in the NFA nodes set. We're going to look at the current. So yeah, for each node in the set of the move function, we're going to search its edges, and we're going to update the res set with the nodes that we can reach, but using one valid edge. So only looking at the edges going directly out of the incoming source node. Only one step is allowed outwards, and we check. Yeah, that should be fine. Okay, so we're building up this, and then the beauty of this is the epsilon thing. I can use the epsilon closure function on the NFA nodes, not that one, on the res. We do it on the res, giving the lookup, and that should update result to also include all the nodes reachable via epsilon edges. So this is void because result gets updated in place, I think. Yeah, because we did the ampersand stuff. Good. And then so I should be able to return res, and it should be happy days. Now result. Yeah, I'm pretty happy with that. Okay, so I think I managed to write a function that I've managed to write a function that lets me do the move operation, and the epsilon closure, which are the two major operations in the algorithm. Now I just need to construct the DFA given an NFA. Given an NFA. Okay, so step one, like we said, is going to be to make the lookup. So NFA node lookup equals get lookup given the NFA. So we've got our lookup now. What's wrong with that? Star, sorry. So given that, we get the thing, and then we have to say, I need to make some kind of queue. Did I make a queue last time? Yeah, I did. So we're going to call this DFA node Alright, here we go. So we're going to create a DFA node queue called Q is equal to DFA node Q init, and we'll give enough space based on the number of NFA nodes, I guess, would be my rough guess. We'll see. I mean, it has resizing capabilities if necessary. I hope I don't need to use it, but okay, int Q index or Q head is equal to 0. It's going to be the index we use to DQ. We do all that, and then we have to create, so hash set the source hash set is equal to what am I doing? I have an init function. What was that for? Alright. So hash set starts, we have the source, which is just an empty set. Hash set, we have to add the to the ampersand. To this source, we have to add the NFA initial ID. So that gives us that. Then we have to do epsilon closure on this set, given the lookup. So that will update the set to have all of the nodes in it, such that you can reach those nodes via the epsilon edges. Okay, so that's that. So that is the initialization part. And I have to also say DFA node. I have to append this wait, what? Sorry, first I have to say DFA node. I should make a function called create node, right? DFA node create DFA node. Given a hash set and given given the hash set and maybe given a DFA and maybe num nodes should increase. Set is equal to the hash set, and I should return node. I think that's all I need to do. So I say create DFA node given the hash set, which is the source, given the DFA, which I need to create, and I'll say false for the thing, but that's not can't be sure if it is false. What did I need again? The DFA, yes, I have to malloc that, I think. Okay. And I think I basically have to check if hash set exists in my source hash set. I have to check if the key, which is the NFA terminal ID, I have to check if that exists in there. And yeah, again, by Thompson's construction algorithm, I'm pretty sure there's only one finishing node ever. So that's good. So we have to also make sure we got DFA node. Source node. We'll say source set. Just okay. So the source set versus the source node, and we can say the DFA is start is equal to the source node. Cool. So we have the starting node, and we should also. I think I did this wrong. Hang on. No, it should be okay. Right? Should be fine. And then so yeah, DFA node Q append given. Why is it asking for a DFA node Q again? I would have thought that it would ask for a DFA node. Am I confused? Did I mess it up somewhere? Did I change something by accident? I'm pretty sure something strange is happening. I could be wrong, but should that say label? Oh, I'm dumb. Sorry. No, of course it's right. It's asking for the actual array first. And then I'll put the item. For some reason I thought it wanted the item first, and then so I was getting a bit confused. Okay, so it wants the Q first, which makes perfect sense. Error type, that doesn't seem right. What's wrong with what? Maybe because maybe I need to put this beneath so that it knows what I'm talking about. There you go. The source node. So we're going to yeah, we append that as expected. It should be void, yep. And then while the Q head is smaller than the size of the Q, we're going to say, so this is where the structure comes in. While not empty, take the next for every symbol A. So I need to take the next first, which is Q data Q head plus plus DFA node. So we get the current node, and then for every symbol A. So my thinking, I think I wrote a little bit about this already. So yeah, I was just gonna basically iterate through from like some number up to some number in the ASCII table. This is a terrible ASCII table. This is good. So like somewhere, yeah, from like 32, which I think is space, up to 126. Okay. For char C equals 32. I think normally you want to do something like that. Normally you put the characters, but I think it's actually a little bit, I don't know if it's more or less readable, but I will make the magic numbers constants. ASCII lower, ASCII upper, was what I say, 126? Because the thing is, like, when you do this part of the algorithm, you have to go through every symbol that you could possibly see in your text, I think. Which is like, I mean, this barely scratches the surface, really, but ASCII lower, ASCII upper. So for each one, we're going to apply the move. I need a Zobrist as well. I forgot. Right. Zobrist star Zobrist set is equal to, was it Zobrist in it? Okay. Upper bound. It's based on the number of NFA nodes, isn't it? I think. Because yeah, upper bound refers to like the number of elements that you have to provide the magic keys for, the magic translations for. So that should be fine, I think. Okay. And which means part of the initialization process should be adding the set. So Zobrist add to the Zobrist set, added the set, which is the source set. So not the DFA node, but rather the source set. That's how I've built it. It's a bit difficult to read this though. Yeah, the hash set, you add the source, you add the initial ID, you do the epsilon closure, and then you have enough information to add the Zobrist. Then you can create a DFA node as well. DFA start equals source node. Okay. For this one, move move given the NFA nodes that gives me the hash set, which is what I want, and I want the lookup, and I want the character C, so that's giving me that, and it will return the new hash set, and that's after the epsilon closure and everything. So if Zobrist exists in my Zobrist set, if this new nodes set exists in there, then I think I have to free the new nodes straight away. And I feel like I need to actually get access to the thing, don't I? A DFA node needs a set, needs, yeah, an ID is good, and a Boolean thing is good. I think, but it needs edges as well, doesn't it? but an edge in this case has a neighbor which is NFA node. So maybe I do need to make another dynamic array type. DFA edge. So like type def structs. So yeah, char star still has spelling, but it'll be DFA node star neighbor. And I should probably have this is called DFA edge. Type def struct DFA edge, call it DFA. Wait, so DFA edge, DFA edges. Yeah, so it holds DFA edge pointers and it's called DFA edges. So this should have DFA edges in it, like that. Yeah, should be fine. Okay, let's say if Zobrist doesn't exist, then I don't free. Instead, I have to create a new node, DFA node star node is equal to create DFA node, given the hash set, the new nodes, given the DFA, which I think I just called DFA, given if it's a bool terminal, which is this thing again, does the terminal ID exist? And then create edge as well. Given given a DFA, is it fair game to put just char for DFA edge? Because at this point I'm comparing, like I'm going through every symbol. I think I can get away with just putting a char. I could be wrong, but I'll try it. DFA node. Nope. DFA edge star edge is equal to malloc size of the neighbor is equal to that node. Yeah, I'll call it neighbor, just so I don't get confused. And then edge spelling is equal to spelling. Char spelling. So we create the DFA node, the neighbor node, and then we create an edge, giving the neighbor, which is this node, and the spelling, which I think I can put C for this. And then what, edge star, I assume, DFA. And then basically the current node edges, this is a type of array, so it would be DFA edges append to this guy, put in edge. Which stores a bunch of pointers to edges. Yeah, so that should be fine, I think. Else I need a way of actually getting that node. Which means the Zobrist hash function needs to actually give me back the node. I didn't think that far ahead. The Zobrist, when I look for existence, it has to actually give me back the DFA node so I can use it. Wait, no, but doesn't it store the actual... Oh, it stores a set. It stores a set. Okay, I'm just trying to think about the easiest way to do this. How can I affiliate the address of the actual DFA node to the Zobrist slots? I want to say... What I'll say is I will do this tomorrow or another day, because I think I'm almost there. I just need a way of recycling the node, which means actually getting the address of that DFA node if it exists, if the set exists. Something along the lines of, I really don't have to change the structure of the Zobrist, but I feel like I might have to. What if I make a what if I make like a parent Zobrist, like a custom Zobrist, which stores as the Zobrist as a field in the struct, but also has some kind of way of mapping the Zobrist internals to the addresses that I care about, but that feels a bit wrong. Because like, yeah, what I really am looking for is like key value pairs. So the easiest way to do this would be storing the value of the value of the address as like a void star pointer. So like, hang on. Where's my Zobrist? Yeah. So like, if the struct... but I didn't make the struct public anyway, because I was trying to be clever, but maybe I would make it public then. but yeah, like the Zobrist element that resides in each slot would have both the set as a key, but also um, the thingy-majiggy would have the address to the DFA node as like a value, would be my idea. But I don't, that feels so strange to have to change this internally to make this work. If it doesn't exist, create the node, create the edge, and go for it. If it does exist already, I could DFS. I'm not doing that. Yeah, no, it has to be the Zobrist. That's where the existence is. That's where the information is regarding the existence. So you'd have to tie. All right, let's do this. So what I'll do is I'll say void star value, and in the add, I'll say void star value. It's really breaking a lot of stuff. And you have nothing to add, you just set the pass in null, you know? But where's the add function? Void star value. The element. Okay. And we're gonna pass in the address of the actual source node. We're gonna pass in this pointer as part of it. Now this is all voids does, so, and I'm gonna have to make this public. I'm gonna have to make you public because I have to access the thing. God, like I shouldn't be able to access this at all, but whatever. Else, do I need like a get function? How's that? Wait, what? But it's here, isn't it? Oh, I got rid of the type def. So I'm gonna need a function that lets me get. That's fair enough. Given for int count equals 0, count. Return Zobrist. Okay, this is my scrappy if Zobrist exists, else DFA node is equal to Zobrist get, given the Zobrist set and given the set S, which is this guy, and then this is still the same. And this should be the same as well, right? So in fact, I can declare, I can say get rid of you, get rid of get rid of you, and then something like that. So declare the variable, so it's in the outer scope, and then either create it or get it from the Zobrist. Have to cast because it's a void star, cast it back, make it equal to that. DFA edge. Interesting. It's 1 AM. Well done. Okay, that might be it. That might genuinely be it. Do I have a way of printing a hash set? I can do the iterable stuff if needed. Let me just check something. Print iterable? Yeah. I think you didn't make it public though, so maybe do that. God, really changed a lot of files. Not ideal. But, didn't do enough forward thinking, I guess. While queue head is less than queue size, and every time you create a new node, create DFA node, every time you create a node, you should queue append onto the queue, append this node. And you shouldn't be redeclaring here. What? Yeah, that way the size of the queue increases a little bit, but every time you run the loop, you're definitely increasing the queue head. Okay, cool. The thing is, what I'm doing, for every dot, every wildcard, like every, any match, any dot, I'm creating like 32 up to 100. I'm creating like 100 edges, like 90 edges for every dot. For every dot edge, I create 100 edges, 100 letter edges, 100 edges. Anyway, oh well. I might just initialize this to null, just so that I know it's null. I mean, I don't think it really matters, but I just feel like I should. If it doesn't exist, then create the DFA node and add it to the queue. Otherwise, just get it. Hopefully that works. And then, yeah. And that should be the entirety of the algorithm, hopefully. And then we can have a DFS again. Not here. This needs to return the DFA. And then void print DFA via DFS. Given a DFA. Calloc. Size of a boolean, and I want DFA num nodes. Okay. I didn't really set its fields. DFA so I do the visited, I create the visited array, and then I have a source node because DFA start. Void print DFA DFS. Given source node, given the visited, given what else? Do I need anything else? Let me just take it. The lookup was what the old thing was, so I don't think so. Yeah, you're using the lookup before, but I don't think you need that anymore, so it should be fine. So if visited at the source ID, then continue, not continue, return. Otherwise, visited at the source ID equals true, and then for int I equals 0, I less than source edges size, so for each edge, so we get the current edge. Printf edge from percentage %d to percentage %d. Spelling equals percentage %c. So we say edge from percentage %d, the source ID, to the edge neighbor ID with a spelling of edge spelling. Is that fine? DFA, this one, and then print DFA DFS given the neighbor, which is also a DFA node, right? Yep. And visited. And that should be it. Print DFA DFS given the source node, which is DFA start, and given the visited, and then free the visited. Of course, I have to also make like a free DFA function. Okay. I'm not going to bother with too much, but I will just check. Did I, does this compile? What do I need? I need a bunch of stuff, don't I? So my include directories are as follows. I have NFA. Is that wrong? Oh. Wait, what? Oh, dash I. I'm stupid. Check me out. NFA construction include. I have that one. I have dynamic array. I have primitive. Okay. It will be the hash set include, and then there'll be Zobrist hashing. And the source code hash set source. Okay, this is starting to get a bit dumb. I need to make a thingy. What's it called? Not makefile. Well, makefile, but CMake. I need to do that. So I got the Zobrist. Okay, sure. And of course, it couldn't find anything. Oh crap. I broke stuff. Oh, I messed up. Oh no. I have no clue what's going on. Type def. What? Oh, 3 guards actually. Yeah, I did forget my guards. Hash if and def. I shouldn't have called it primitive. I was dumb. Not HTTP. What am I? This one should have cards, yeah. Uh-oh. NFA node? Oh, this is the wrong thing. What? Why have I done that? Wait, what? Oh no, wait, what's wrong? Wait, I understand I've done wrong. I forgot. So I did want a hash set, but this should say hash set. This is epsilon closure DFS, not the original DFS. Original DFS can use an array, but this one should use a set. Edges, size. Whoa. Overflow converting. Okay, I guess I didn't want. I'm very happy to get rid of this case. Implicit start. Do I not have a main? Oh my god. Non-void function. 160. Oh my god. Okay. It compiles. We'll call it there.